This is lesson 10.4, and we're going to talk about inscribed angles. So an inscribed angle of a circle has its vertex on the circle. The measure of an inscribed angle is equal to half of its enclosed arc. So, for example, if my arc was 50 degrees, then this inscribed angle would be 25. So we've got case 1 here where we have it on a side of the inscribed angle. We have it inside, and then we have our center being kind of in the exterior. So it still applies to all of these different cases. These are all still considered inscribed angles. So here, if this is 124, what is inside here? It is going to be 62 because it is half. What if we know the inside angle? Well, then we would double it in order to figure out what D is. So we would take 52 times 2, and we would get 104 degrees for the arc measure. So this one, the inscribed, we would go and we would double it to get our X, which is going to be 144. And then in order to get this one, that's the central angle, we know that these are the same. So we would go ahead and just put 144 for our Y. When it's at the center, it's the same. When it's all the way across and on the circle, that's when it's our half or double, depending upon which direction you're going. So for P, we would go half of 70, and so we'd get 35 degrees. For PO, we would double it, so 2 times 56, and we would get 112 degrees. Over here, if we're looking for CF, we would kind of highlight that arc and then we'd see what angle is across from it, so 40. So that means that we are going to double our 40 and get 80 degrees. So think arc is bigger and then angle is smaller. And so for C, if we want angle C, we kind of look to see what the arc is that is across from it. If that's 98, we would take and cut it in half. So 49 degrees for angle C. What if we have 2 inscribed angles and they share an arc? Then those angles are going to be congruent. So B and C would be congruent because they share that arc AD. So if we look at kind of this angle, it's across from AD. And then if we go this direction, this angle is across from AD. So these two share arc SV, so they must be equal to each other. And so we would go ahead and set 3x minus 5 equal to 2x plus 15, and we would solve. And then it looks like we're trying to find t, so we're going to go ahead and plug it back in. So if x is 20, it would be 3 times 20 minus 5, which would be 60 minus 5, or 55 degrees. If I want angle C, and I can see that this is across from arc AB, and it's 75, and C is also across from AB, then it has to be 75 degrees as well. If we have an angle inscribed in here, and it is a right angle, we know that it's 90 degrees, and then it is at our semicircle. So every time we have it and going through as the diameter or a semicircle, it's always going to be that 90-degree angle. So we can go ahead and add all 3 of these angles up. Since it's a triangle, we know its total is 180. So adding including the 90-degree angle, and we set that equal to 90, we would get 13x minus 2 equals 180. So 13x is equal to 182. 182 divided by 13 is 14. So if x is 14, we could go ahead and plug it back in for f and do 4 times 14 plus 2. And that's going to give us 58 degrees. So if this one is our angle across here from it's in the semicircle, or it's across from our diameter, we know it's a right angle. So 3x is going to have to equal 90 degrees. So x is going to equal 30 when we divide by 3. And in inscribed quadrilateral, we've seen this before, but the opposite angles relationship we are going to learn is supplementary. So they add up to 180 degrees. So if I know that this one's 60, then I know that x has to be 180 minus 60, or 120. And this one being 95, I know that 180 minus 95 is going to give me 85 degrees for y. And we can go ahead and solve these, knowing that across from each other those are supplementary. So go ahead and take a moment to solve for x and y, and check when you're ready. Hopefully you got 95 degrees for x and 100 degrees for y when we subtract what we know, which is 85, just solve there, and 180 minus 80 for there.